So just a quick show of hands while we're getting some other people seated. How many of you have heard of the Cynefin framework? Oh, it's a fair few of you. Okay, so I can do it quite quickly today. How many of you, when Dave Farley in the last talk said, you know, the Cynefin people in the room went, oh, that's me? Few of us. Oh, I'm not the only one. That makes me very happy. Okay. All right, so the thing I want to talk about today is I tweaked this talk because I know we've got a lot of developers in the audience. So I've done this talk before, but this is a very different version just for you. How many of you like being in planning meetings? You're going to love this talk. I'm going to give you some tools for getting out of planning meetings. That's really what this talk is about. Okay, so this talk is about a thing called apophany and how it affects our brain. So the word apophany was originally coined by a German psychologist called Klaus Conrad. And you've probably heard of epiphany, right? Epiphany is that sense that we get that we go, oh, I get it. Okay, so apophany he coined for the sense that schizophrenics get when they go, oh, I get it, but they're wrong. And it's come through to English as the term apophenia, which is our tendency to see patterns that don't really exist. And we all do it. Are you ready to experience some apophenia? Great. What is it? Can you see the elephants, right? It's actually a lava flow on Mars. So you're probably more familiar with the idea there was a face on Mars. There's also an elephant on Mars. If you can't see the elephant in this one, how about this one? This is Elephant Rock in Iceland. How about this one? It's not a trick, that's an actual elephant. Does anyone know what kind of elephant that is? It's an African elephant, right? You can tell because of the big ears. And this one? It's an Indian elephant. It's actually a subspecies of the Asian elephant. How about this one? Baby elephant. It's not. It is a full-grown male. It is an African forest elephant. If you're like me, you probably grew up thinking there were only two types of elephants. There's African elephants and there's Asian elephants or Indian elephants, right? Turns out there's a whole other species. So the African forest elephant, the African bush elephants and the African forest elephants are very, very different creatures. The African bush elephants and the African forest elephants are smaller and they're darker, and they even have different numbers of toenails on the feet. You can see the skulls are totally different shapes as well. And these two species of elephants don't actually interbreed. But they didn't find out that there was another species of elephant until 2002, which is how half of us don't know about it. I was super excited when I was looking up facts about elephants and I found this out. But it's a problem with this. It turns out that back in 2002, all of the people looking after elephants, all of the ecology folks trying to protect the elephants, they weren't counting them as two separate species. They were just counting them as African elephants. So they had absolutely no idea how much of each there was. And it was really, really hard for them to change their processes to start counting them, because they had fixed their processes in place on the basis that there were only two types of elephants, African and Asian. And they were just counting African. So they didn't know whether one type was more endangered than another. This is a discovery that has been waiting to happen for millions and millions of years, right? This has been in place for a very long time. And yet we're still making these discoveries today. How many more discoveries do we make when we're dealing with software development and things that are changing on a daily and hourly basis? What happens when we fix things in place? The reason this happens, this fixation that we get, is because there's so much data in the world. And we cannot possibly take it all in. We would go crazy if we spent all our time trying to work out whether the thing we think is one species is actually two or three. In fact, there are a lot of scientists who do this, and they're quite mad. But we observe all these data around us. If you think about what you can actually see in this room right now, the colours of the chairs, the clothes that people are wearing, the echoing sounds around you, you can probably smell some stuff, you can feel a ton of things. If you tried to pay attention to all of that at once, your brain would not be able to cope with it. So we filter the data that we observe. Okay, and this is the ladder of inference by Chris Algiris. So we filter the data we observe. And then what happens is we make some assumptions based on that data. And the assumptions are often either instinctively coded or they're things that match our experience. And we draw conclusions based on those assumptions. And then we create beliefs. And the problem is we use those beliefs to filter our data. This is a reinforcing feedback loop, and it's known as confirmation bias. It is one of the ways in which our brains are broken. We really like having confirmation bias. We like having the patterns that we think exist be confirmed. We like it so much, we would rather have bad outcomes than hold on to uncertainty. And there are tons and tons of experiments that have shown this. This is one of my favorites. This was done by University College London. What they did was they got people to play this electronic game where they hid snakes under rocks in the electronic game, right? And if you turned over a rock with a snake underneath it, you got an electric shock. And the goal was to try and you had to learn how the snake population behaved. So you end up not getting shot so much. But they varied the probability of snakes under the rocks, and they measured people's stress levels while they were playing. Turned out the people who were most stressed were not the people getting hardly shot at all. They were quite happy. I hope they were being paid for it. It wasn't the people who were getting shocked more often than not either. They were kind of inured to the fact they were going to get shot. It was the people who didn't know whether they were going to get shocked or not, the people at 50%, snakes under rocks. And they had the most incentive to solve the game the quickest as well. They were best at solving the game, the quickest at solving the game. Right? And there's been all kinds of studies around this. We are really, really bad as human beings at dealing with uncertainty. Really bad. And so we have these conclusions that we jump to as a result. So there's a little story in a lot of different cultures. This one I think is Chinese, about these blind men who come across an elephant, and they'll feel the trunk. They feel the trunk and they go, oh, it's a snake. Or they feel a leg and go, oh, it's a tree. They feel the tusk, they go, it's a spear. And in many of these stories, they actually end up coming to blows around what it is they've got hold of and the massive arguments over it. And it reminds me a lot of architecture discussions I've been in. Okay, so confirmation bias there's a whole ton of things that count as confirmation bias. It's really, really big. Apophenia, we talked about. Pareidolia is actually a subset of apophenia, which is our tendency to see patterns in meaningless data, random data. The elephant's faces is a really common one. But there's others. There's the actor-observer bias. There's Google effect, one of my favorites, our tendency to forget things that we think we can look up later. Because it's all about our limited time, limited attention. Illusion of control, insensitivity to sample size, omission bias, negativity bias. And I see, oh my goodness, there are so many of them. This is how broken our brains are. Dave Snowden actually says, I'll talk a little bit about Dave Snowden, he's the guy who created Cynefin, but he said these aren't actually biases, they're heuristics. Most of the time they actually work for us, and they're sensible ways of navigating this ridiculous amount of data that we would otherwise have to deal with, right? So they're sensible ways of being, and they're only a problem when they go wrong. And they generally go wrong when we're dealing with uncertainty. So he says there's a fundamental assumption in the world, a certain level of predictability and order that people assume exists. And this is particularly true in business, and it's particularly true if you're dealing with project managers. It used to be true when you had a factory line. It's not so true anymore. It's not so true in software development at all. So I want to talk a little bit about why that's the case. You already heard quite a lot of stuff from Dave Farley, so I'm really hoping this fits very nicely with what he said. But I wanted to show you something called the innovation cycle. So Dave talked a lot about the need for experimentation, the need for innovation, evolution. I always use cameras on a phone as an example. So back in the day, the first ever cameras on phones were from people like Sharp and Kyocera. They actually put the camera on the front of the phone facing towards the user, and they had it portrait style or landscape styles because they thought people would use it for making video calls. And it turned out people didn't really want to do that. The internet wasn't set up for video calls back then. And then, of course, Nokia came along. And Nokia saw the things that Sharp and Kyocera were doing differently. And they went, we see your fun. We're going to spoil your fun. We're going to do that too. But they put it on the back with a little mirror so you could take a selfie. Do you remember? The little mirror on the back. So thank you for that, Nokia, inventing the selfie. How many of you have got cameras on your phone? How many you've got two, one on the front and one on the back? Right? It's become commoditized. And so a whole ecosystem has now built up around the fact that we've all got cameras on our phones. You can get things like Pokemon Go, which relies on you being able to video the world and see things which aren't really there that are added to it by the app. Okay, so we now build on that ecosystem. And as a result, more differentiators emerge. And this cycle of things being built on other things, being built on other things, that's that escalating graph that Dave showed you. Okay, so you'll see this thing in the background. Oh, sorry, I've got one already up there. You'll see this thing in the background. This is the Cynefin framework. So I want to introduce it briefly. I'm not going to go into it in too much detail. There is an article called Cynefin for Everyone on my lizkeogh.com blog site if you want to go read that. It's a nice introduction, but I'll do it really quickly today. So the first kind of, there's 4 different domains, and they describe different problems, different situations, and how to approach them depending on how predictable or unpredictable they are. Things do move across the boundaries, so the boundaries are fuzzy. Particularly this boundary over on the right here is not a threshold like the other boundaries are. So you have these problems which are clear. Used to be called obvious, and it was called simple before that. But the idea is that it's stuff which a child can solve, right? You can know how to plug into the wall. Children can put plugs into the wall. And you can categorize a problem. You go, oh, it's one of those. I know how to solve that. It's a dull problem. Dull. I know how to do that. But as things become more complicated, they require more expertise. So a watchmaker knows how to fix your watch. A car mechanic knows how to fix your car. Still predictable. You can correlate cause and effect easily in the clear domain. You can correlate it with expertise in the complicated domain. And because you can close the gap between what you're expecting to happen, what you think should happen, and what is happening, that's called analysis. So experts can analyze the problem and then just close that gap. This is the domain we like the least, chaos. Chaos is accident and emergency. It is your house falling down or burning down. It is a transient domain. It resolves itself very quickly, not necessarily in your favor. It is dominated by urgency. If you have time to try things out and experiment safely, you are not in chaos. Okay? Chaos is really fast, at least on geological timescales. I'm a climate change activist, so I keep talking about, like, we're not good at seeing chaos when it's slow. In chaos, you have to act and act quickly. And you might get it wrong. There might not be a solution. The one that trips us up is complexity, because cause and effect are correlated in retrospect. They're not correlated at all in chaos. If you try and work out why the fire started while you're still in the fire, that's not going to go well for you. But in complexity, we can see with hindsight how things happen, but we couldn't possibly predict it. And so we have to do what's called probe. And it means to try something out that's safe to fail. You can think of it like experiment, but generally hypotheses in complexity don't work quite the way you think. And I'll talk a little bit more about that later. Okay, so what does a probe look like? How do you know you've got a good probe? It's got to have some indicators of success. They are only indicators, not measures. More on that later. Indicators of failure, so you've got to have a way of knowing, a way that you think you know you will know it's succeeding, a way you think you will know it will be failing. So the things you're going to pay attention to and be curious about. If it's failing, you want to be able to dampen it. And if it's succeeding, you want to be able to amplify it. So this is one that a lot of people miss. They'll try things out, but then there's no way of actually making it carry on working. There's no way of actually continuing for that and keeping that thing alive. Okay, so don't forget you've got to amplify it as well. And then it's got this thing called coherence, and coherence is a realistic reason for thinking it's a good idea. Dave Snowden says a sufficiency of evidence to progress. Okay, so what does that look like in software development? Spikes, prototypes, proof of concept. I've got this little table, it's on one of my blog posts, around the different kinds of spikes and proof of concepts and probes that I see in software development and who they're really for. So spike's the smallest one, might take an hour or two. It demonstrates to us, the team, to me, the person doing the spike, that, oh yeah, okay, I understand how that tech works now. Right, so it's still really high learning. Proof of concepts and prototypes, we tend to be trying to prove it to somebody else. Alpha, now you're getting real users. Early adopters and innovators will work with you to try and tweak things, and they don't mind too much if there's a few bugs, but by the time you move to beta, you probably want to have the bugs ironed out. That's like your last chance to get feedback and tweak and make sure it's really fit for purpose. By the time you get to release, you've got to have something that's a good, stable product. And I'll talk again a little bit more about how that happens. Okay. So there are some interesting constraints in the Cynefin diagram as well, and that's what I really want to talk about that's a bit different today. In the clear domain, we have fixed constraints. And it tends to be the case that there's only one way of doing things. So the clear domain has best practices. You can think of putting a plug in the wall, right? Okay, we might have a different plug to the one in Europe, but you know how it works. Then you don't have to try, oh, I don't quite know how this does, unless you're using one of those old USB plugs, in which case, good luck. But there's only one way to put it in the wall, right? It's fixed. When you start getting into the complicated domain, you get governing constraints. These are context-free rules that apply pretty much all the time, or apply in your context, in that grand scheme. I always think of red lights, right? Sure, police cars can go buzzing through red lights, but if you do it, you're going to have a bad time. Okay, and they're specially trained to be able to be the exception to those rules. I did say the borders were fuzzy. Okay, but governing constraints, they're things that just always apply. So you can think of things like the offside rule. You can think of things like, we're in football season, right? So you can think of things like the outline of a pitch. The ball can't go outside the outline of the pitch. If it does, it's out of play, okay? When you get to the complex domain, you have enabling constraints. And these tend to be heuristics. These are guidelines. These tend to be attractors. They're things that you want to head towards rather than things that contain you. And they tend to be more flexible. Governing constraints, when they break catastrophically. With complex domain and your enabling constraints, you usually get a bit of warning. So as an example, I'm not a huge fan of PRs, but they do provide an enabling constraint. There were usually some people in the team who can escape the process of PRs, and you can always ask to be one of those people if you really need to. And just bypass the PR process. So it is there, it's enabling, but you can escape it if you need to. One of the things I do as an Agile coach is I look to see what rules exist that are actually stopping people, and can we make some holes in them? Can we make some exceptional cases? Can we turn them into more of an enabling constraint? Chaos is chaos because there are no effective constraints. Fire burns until it runs out of fuel or it meets some boundary somewhere. Right. I always use Knight Capital Group as my example of software bugs. They didn't have a constraint on the amount of money they were able to lose. By the time they found the software bug that they had introduced on the Monday morning, it was £45 million later. And they went bankrupt as a result. Right? So the only constraint on them was how much will the market allow us to die? Okay. So have you ever seen a Wardley map before? Who's seen a Wardley map? Couple of people, right? So this is one of my favorite tools for looking at software generally. And you can think of it a little bit like an architecture diagram or like a system diagram. This one is a little bit more simpler than the Amazon diagram that Dave showed us earlier. The idea is that you put visibility to the customers at the top. So you put your customers at the top and then you go, okay, what do the customers need to get this thing? And what does that system need? And what does that system need? And what does that system need? And over on the x-axis, you have how stable the system is. So you start with this Genesis stuff. Genesis is usually done in what we call a shallow dive into chaos. So you separate people so they have nothing to lose. And you give them some limited time to go get some ideas, like a hack day. And you go on then, and show us what you got afterwards. And crazy ideas will come out of it. Some won't work, but it's OK. As long as you've managed the exit from chaos, it's OK. So Genesis, weird, wacky ideas. No kind of products coming out at the moment. But then some of those will become things that you actually want to go with, you actually want to build. So now we're in the custom built domain. Agile rocks here. Agile rocks for custom built stuff. It's really good. But some things we don't build, we just get them off the shelf. We use open source. And those are stable products. And usually our goal is to take our custom built thing and turn it into a stable product. And then down the far end, you get the stuff that's commoditized, that we don't really think about being there. So at the time Simon did this drawing, power was down there, but he said, you know, platform is moving that way as well, because this was when AWS started coming in. And now it's just available on tap. And people who use it don't really think a lot about the fact that it's just there. And it's super, super stable. So you can see the stability increases as we move to the right. The act of moving the stuff is also complex. So you can see, like, it's going to be complex if it's in the custom domain. We're going to have some tweaking still going on. There'll be complex stuff coming into the products. So every new feature we add is going to be complex. But the act of stabilizing something for the first time is complex too. And he's got this lovely little black bar that shows the inertia of getting from one phase to the next. Most of what we do is getting over that inertia. It's introducing your DevOps for the first time, you know, your build pipeline, introducing your continuous delivery, teaching somebody TDD. Yeah. The constraints also increase. When we have custom-built software, trying to absolutely insist that there's 100% test coverage can actually slow down some of the more innovative folks who they can't write clean code to save their lives, but they can really hack something and get it working. And then you want people like me who do TDD and refactoring for fun and really love it to come along afterwards and tidy it up or rewrite it and get it into a production-ready shape. But treating those with the same process, as we so often seem to do in our teams, doesn't make a lot of sense. For the product stuff that's been around a while, you're going to have experts available. There are going to be people who know how to use Jenkins. We've got some experts at the clients I'm working with at the moment who are really good with Jenkins and build files, just mind-blowingly good. But we're not trying to write Jenkins for the first time. The stuff we're trying to write for the first time, there's a lot of lack of expertise around it. There's a lot of noodling. There's a lot of experimentation going on. So in the clear domain, we have these best practices. In the complicate domain, we have good practices, because there's often more than one way to solve the problem. Jenkins, TeamCity, I don't care. In the complex domain, we get emergent practices. And the problem I see with a lot of Agile coaching is when people come in, they go, you must do Scrum this way with story points, which aren't part of Scrum, but everybody teaches it that way anyway. Right? And you must use Scrum's Jira board, you know, Jira's Scrum board. Don't do that. They're horrible. Use the Kanban board. Okay? You're going to develop your own practices. You're going to develop your own ways of doing things. And it's going to be fitted to your little context. So coming in and trying to impose the same process, even on one set of requirements, let alone on all the different teams, it's going to be problematic. Chaos generates novel practices because people have nothing to lose, and they will try stuff. If I get time, I can share a story around that. Okay, so I talked a little bit about this shallow dive into chaos, this idea that we can separate people and come up with ideas for experimentation, for turning into custom-built stuff that may eventually become products. There's also this little liminal threshold between the complex and the complicated. A lot of our software actually ends up being in that space where we kind of have an idea of what we're heading towards, but it's still very iterative. It's still incremental. You know, we're still tweaking things. Okay. So when I first started talking about Cynefin, back in the early days, people said, yeah, but it doesn't have any actual practical effects. So I thought I would share this with you. I was talking to Sal Freudenberg about Cynefin. I said, well, it feels a certain way in my head. And so when I come across the same things in software development and the process feels that way, the thing I'm working with feels that way, I just instinctively know which domain I'm in. And this is what it looks like. Right? So it looks like bricks and really easy stuff, like noddy child stuff. In my head, this is how I visualize really easy stuff like CRUD web forms. Okay, and then as you get more and more complicated, it's a bit more like Lego Technic with all the cogs and all the gears. And then chaos is always on fire and everybody's running around screaming, going, oh, the production bugs. Right, and then you've got the organic stuff, the living stuff. I'm using elephants in this talk, sometimes I use plants, but we're having an elephant theme talk today, all right? So this is how it feels in my head, this is what it looks like. And I said this to Sal, I said, I don't get why people get it. You know, how can other people not have this picture and not understand how to use Cynefin? She said, Liz, not everybody visualizes the way you do. Do you know you're autistic? And I went, oh. Right, that was a revelation to me. But I know, from having spoken a lot to Sal, who does have a degree in psychology, that a lot of the developers out there might be a little bit on the spectrum as well. So hopefully this is helpful to some of you. Right. Unfortunately, we all have this sad elephant in our head. The sad elephant, when we try stuff, goes, that won't work because... And I have been in so many architecture meetings, so many planning meetings with the sad elephant in the room, and you go, I'd like to do this, and they go, that won't work because, have you considered this? How is it going to work with this other thing? I go, oh, okay, and you go away and you think about it some more, and then you try again, and they go, but we thought of some more gotchas this time. And it's really hard to get anything done when you have to get it through the architecture group first. Safe to probe does not have a way of avoiding failure completely. It has a way of making it safe. Okay? So I like, there's a guy called Peter Palczynski. He was a Soviet engineer. He says, you know, if you're going to fail on a scale where failure is survivable. So do it small, do it with less time, less people, less money, right? Fail small. He didn't listen to his own wisdom because he went and tried to espouse these things at large in the Soviet Union and got executed for it. So yeah, careful who you talk to about this. But this is the really exciting thing for all of you, okay? Complex stuff resists analysis. We don't have enough expertise to know which scenarios are going to apply, which ones are going to be out of scope. We don't know how the users are going to respond to it. And as soon as you start down the analysis path, you end up in these big thrashing sessions where everybody's trying to think through all the different scenarios that you have to consider. And it takes hours. And you end up in this session where they go like, how many story points? Liz, why did you vote 13? I don't care. Can we please just get out of this meeting and write some code? All right, have you been in those? Okay, here is how you get out of them. This is new and we've never done it before. It seems risky. Project managers really, they snap at that word risk, right? Leaders generally, they don't like risk. They don't like uncertainty. They want to get rid of the uncertainty. Can we de-risk it with a spike, a prototype? And you as developers, you have this power. Most of the time when I propose a spike or a prototype, they go, oh, and there's such a sigh of relief. They go, yes. And that you can agree a time box on it, like, can I take 2 weeks? We might have a better idea of how long this is really going to take then. How are you going to estimate something you've never ever done before? It will take 3 months. Well, that's too long. It will take 1 month. Yes, okay. Right? It's insane. It's absolutely insane. I know yesterday, Sue said, people go back into the JIRA tickets and massage the figures to make them match reality afterwards. Like, everybody cheats. And this is why, because you can't estimate something you've never done before and you have no expertise in. You can estimate at scale, like that looks like roughly 3 months. I've got a whole thing around capability-based planning and lightweight analysis, if you want to go look at my blog post on that. Capabilities are a nice scale to estimate at, but you can't always get it right, and it only provides coherence, okay? That's all that these plans provide, a realistic reason for thinking that it might have a positive impact, a realistic reason for thinking this is a good idea to try. I like going, can you give me an example? Can you give me an example of what it looks like if this succeeds? And if you can think of an example, it's probably coherent, okay? And then you go, is that example going to be worth 3 months we think it might take us? Can we do it for 2 weeks and see? Okay, so there you go. In high uncertainty scenarios, the examples you think of, and the estimates and the plans, they provide coherence. They are not tests. And heaven help anybody who decides to put a target date on the end of something that's highly innovative. I always differentiate between deadlines, where it's like Christmas, nobody's going to move it. If you don't get it done by Christmas, the opportunity will die. People are usually very pragmatic about the scope of what they can achieve when it's Christmas. And sad lines, where no opportunity will die, but if you don't make it, somebody somewhere will be sad, right? People behave in all kinds of weird ways around sad lines that they don't with deadlines. Okay, so a little bit of a story around what happens when you actually try this stuff and you do experiment. I went to see this little company, lovely little, very agile company, very experimental culture, and they had this graph framed on the wall. It had numbers in hundreds at the top and timeline in months on the bottom. And I went, that's an interesting graph. Is that your bug count? And they went, yes, it is. Good guess. I said, what on earth happened? They said, our bug count was rising and it got to unsustainably high levels. So we said, what we'll do is we'll hire a new dev into the team, we'll rotate an existing team member for a bug fixing role. So there's always somebody just focusing on fixing the bugs. And down the bugs went. And then it worked so well that we thought we'd hire another dev into the bug fixing role and do the same thing again, rotate another existing team member. And the bugs started to go up. I said, oh, was the new dev no good? Now, bear in mind, I've never met this person. I've just done the Epiphany thing, right? I've jumped to a conclusion about him. It was a mostly male organization. They actually did those telephone services that sometimes people like to use, where you've got a Russian woman on the other end. They did all of that. Their production servers were interesting. But they rotated another person through this bug fixing role and it started going up. I went, was he no good? Oh, did the team get complacent? They said no. So I'm judging the team now. Team get complacent? No, it wasn't that. So I'm going through all these guesses. Was the software more complex? And they're like, no, these really big smiles on their face. I said, well, where were the bugs coming from? They said, the users had spotted that we were fixing them and started reporting them. You often get the exact opposite in complexity of what you expect. There's a thing called the Cobra effect, which shows the other way around, where they asked the people of Delhi, they said, there's too many cobras, we will pay you if you bring us dead cobras. What do you think the enterprising people of Delhi did? Bred cobras, right? So you often you have to be so careful about the gamification stuff. Jess was talking about games and how you get incentivized yesterday, right? So Yeah, be careful of it. Okay, so what can you do that's useful? This is a thing by Cognitive Edge. They're now called the Cynefin company, actually. They've rebranded. But they have a tool called Sensemaker. And Sensemaker collects stories, and then you signify your story. So you move, or you say, here's a story about my life in Singapore, and you have a little triangle, and you move the icon on the triangle to say past, present, future. I like this. This is what a fitness landscape looks like when you start mapping out where those dots lie, and you can bring multiple measures in together. So these actually represent people's stories. But I think visually, I always have this kind of image in my head when I'm wandering around an organization listening to stories. So you can think of this just like the stories being told in an organization. Stories we tell ourselves form our culture. Okay, so this is essentially a map of people's culture. And you can see where this blue arrow is. We've decided that that top right is where we really want to be. But down here where this blue arrow is, they're not in a good space. And we want them to be in top right. So we're going to go and hire the safe practitioners and impose safe on everybody and go, yeah, we've moved to the top right, because that's going to work. Okay, it doesn't work, because culturally it's not a good fit. These are people who don't know TDD. They don't know BDD. They don't have a Jenkins instance. But next to them, there are some people who, okay, they don't have a Jenkins instance either. Still not got their continuous delivery set up. They've still not got their continuous integration. But they are starting to have fun with TDD. And they're very similar to the ones down there. And I go in and I hear these stories of this other group who are doing some TDD. I go, okay, if there's support for that in this organization, even for these teams that don't think of themselves as agile, maybe that's something we can get started with. So I know yesterday was talking about the Agile fluency model. I really love that as a way of thinking about what do you want to adopt next. It's not about jumping to an end state. Agile isn't an end state. It's about how do you move people to the next thing. And the stories give you an idea of what the adjacent possibles might look like. The low energy changes for which there is support in the organization. So listen to the stories, use the existing disposition, right? So complicated stuff has predictability, complex stuff has disposition. Somebody once asked me what difference was between complex and complicated. I said, well, is a football game complex or complicated? They said, I don't know. I said, is it predictable or not? They said, it depends, are England playing? I said, that's disposition. We could win. I'm actually fancying our chances this time round. Makes a change from the 2000s, right? So you want to use that disposition, use the stuff that's likely to work, and move to those adjacent possibles. That's amplifying the positives. That is what amplifying working probes looks like. There's a thing in improv where you build on what people are giving to you, right? You go, yes, this is brilliant, and this other thing, okay? So we're not saying you're doing it wrong. You're saying, I love what you're doing here. I love the code you're producing. It works. And I'd love it to stay working. Can we learn some TDD? I'd love it to have some more documentation. TDD provides living documentation, even more than tests. Okay? So you can build on what the awesome stuff that's already happening and use the stories to help amplify it. I get more change by going to this other team and getting them to teach the first team than I do by teaching anything myself. Just going and getting the stuff that's working and sharing it. So I just wanted to share this little experiment with you that's obviously, this is a working probe which has been amplified. This is Dr. Lucy King. She works for a company, an organization that saves elephants, savetheelephant.org, I think it is. But she has this lovely thing. She works with farmers in Africa. And the trouble with the African elephants is they're very big animals, and they are very hungry animals, and the farms have lots of food. And the farmers put up these big fences, and the elephants go, okay, walk straight through them, because they're elephants, and they can smell the food. And then it ends up with a lot of tension between the farmers and the elephants, and then the farmers try and shoot the elephants, and then the elephants stomp on the farmers, and it's just not fun. So they had to have a way of keeping the elephants off the crops. Elephants do not like bees. Elephants turn out to be afraid of bees. I guess they get in their big ears or something, but they really hate bees. So what they've worked out is that you can build beehives in a fence, and the bees keep the elephants away. And you get honey as a nice byproduct. But the elephants also have confirmation bias. And they also don't like uncertainty. And you can also trick them into seeing things which aren't really there. Turns out you don't need actual beehives to be in every, you can get away with every other beehive being a real one. And put fakes in the middle and they will not know. Okay, so there we go, elephantsandbees.com. So that's what I want you to take away from this really is the most important thing you can do is experiment, try things out, propose experiments, but remember to amplify the experiments around you that are already working. Maybe you've got something that you're doing that's new, share it with somebody else. Do your tech talks, do your brown paper, your brown bag lunches, right? Do the things which spread the working probes, because that's what gets them from being an experiment, a probe, a proof of concept into a working, stable product. It's what gets your culture in your organizations from being, you must consider all the things in a large analysis paralysis architectural board session, to we've got a thing, it's working, we can demonstrate that it works. And we had fun doing it and we didn't need to sit in a room for 4 hours. Okay? I have one last request. I am a climate activist. Today's CO2 is up 0.4% on this time last year. Please think about what the right thing to do, the next right thing to do. Think about what the adjacent possibles are in your life, things that you could change, things that you could share and spread to your friends. I like sharing eat less beef and take your pensions out of fossil fuel. Right, those are 2 things you can do as individuals. I might persuade conferences to serve less beef as well. That would be nice, okay? That's all. That was it.